This is the fourth video for tools for your GIS Tool Bag number 1. So this will be number 1D. I've turned on the buildings for South Lakes High School attended zone, and I made sure I was signed in into our organization. I'm not sure we need it to be, but since we're going to be using an online elevation model delivered through ArcGIS Online, I wanted to make sure we have access to it, and that may require being logged in. Okay, so after loading the buildings, we're going to click on View. All right, and under View, we're going to go to where it says Convert, and you'll notice there's an arrow pointing down. Click it and choose Local Scene, since we're just interested in a small area of the Earth. And you'll notice that it's made a new map feature up here called Map 3D. Our original map was the horizontal planar map, and that pane is still here. We could switch back and forth between the two, but now we're working actually in a new layer. It doesn't quite look as clear, and that has something to do with it being a 3D rendition. And you'll also notice that down here in the bottom left in your contents window, we have this feature, we have a list of features under elevation surfaces. It says ground, and here's that world elevation 3D terrain 3D from ESRI. What we need to do now to do anything interesting with this is click on ground at the bottom here, and then up at the top click on appearance that's been highlighted, and you'll see that we have our vertical exaggeration set to 1. And what this does is it allows us to make our landscape look a bit more dramatic. Although we walk around here and we get tired riding our bikes up hills or walking up and down the hills, in reality we live in a pretty flat place. So if we click the V key, letter V on your keyboard, V is in vary, and then click and drag upward, we can turn the map sideways. And if we roll the mouse backwards and forwards, we can zoom in on it. We can hold the V key again, and we can go left, right, and swirl it all around. Okay. And I'd like to, now I'm pushing it away. I'm not holding the V key here. I'm just clicking and dragging. And here I'm clicking, I'm just rolling the wheel. Now I'm dragging left and right, rolling the wheel. Okay. So there's South Lakes High School. You can see the large feature there. In fact, I think I'm going to change the color of my buildings. See if I can make it a different color. Properties, make the color, make it bright orange, and apply it. Here you go. Okay, there's South Lakes right there. And I want to push the map away a little bit and zoom in. You can start to see the pixels. That's okay on our elevation model. Now to talk about this a little bit. The elevation model, in previous versions of ArcGIS, you actually created your three-dimensional terrain by extruding that layer. I'm talking about the one with all the pixels and the stream valleys. But we're not using that right now. We're using this elevation, this world elevation model, and it seems to be superior in a number of ways. I think its resolution is changing depending on how close we get. So the farther out we are, it uses larger raster. Pixels are bigger. If we get in closer, they seem to get smaller because the resolution, I don't see the resolution deteriorating. But if we use our own digital elevation model, as we zoom in on it, those pixels become very large. 30 meters is big. It won't look as realistic. But we still need to use it for other things we will do with the raster, with data analysis or raster data analysis, and including things like slope calculations and aspect calculations. But for the rest of this lesson, we're not going to need it, so I'm going to turn it off. And there we go. And wait for the buildings to come back. they're slow. Turn them off. I may have to just move around a little bit to get it to work. Here they go. Okay. I'm going to move the attendant zone to the top. It's just a little, it's behaving a little slow. Oh, there we go. All right. Now I'm going to try to zoom in on it. It's hard to tell, but it actually is 3D. If we move this down to the horizon, you can start to see some of the land isn't actually flat. You can see the mountains in the distance. But in order to make this show up a little better, we're going to go up here. We're going to click on ground again, down at the bottom. Click on ground on the bottom left. And let's make our vertical exaggeration. If we just click it and change it to 2, and then wait for a moment as it calculates, it's simply going to double the elevations. Let it calculate. Yeah, you can see it now, right? Okay, it's a bit more exaggerated. So I'm going to use the V key so I can turn the pointer into that globe with the arrows on it and come in from an angle like this on it. Now you can see there's curvature. Okay. And this is the perspective I'd like. I want to be looking across this neighborhood. This is Lake Audubon, Lake Thoreau, Langston Hughes, and South Lakes. So what we'll do now is we're going to extrude the buildings. So we're finished working with the ground level. So we're now going to just click on and highlight South Lakes buildings, and you notice our toolbar changed up here. This time, pull down under this XY graph here with the green bar, choose base heights. And wait a minute. And now we're going to choose, for the extrusion field, we want to use the top elevation of the buildings. And then we're going to keep it as US feet. Oh, there they are. Now what happened here? I'm not exactly sure why these buildings are so tall. The values are in feet, but the height of these buildings looks like it's in the meters. So it's possible that the map unit is meters, and it's looking at these values in this field, in the buildings field that gives the height, and giving us 23 meters instead of 23 feet. So we can fix that. We can click this X right here, this expression, open up the expression box, and next to where it says top elevation, click, hold down the shift key, and click the number 8 to get the asterisk, and then let's type in 0.5. And run it. It'll take a minute. Okay, they're shorter, but that's not short enough. So let's change this. I'm going to go out on a limb here to get it close to something that I think it might be. Let's change this 0.5 to 0.06. Oops. Okay, got a problem with the expression. I have 2 decimal places in there, or decimal marks. Let's try it now. looking better now. All right. So now let's zoom in a little bit on South Lakes. So a combination of rolling the wheel and dragging. Okay, so let's use our measuring tool. Go to Map, click the measure, but this time let's use Measure Vertical. And let's measure the wall of the school from the top to the bottom. Okay, it says 23 feet. Now I don't know if that's the height of South Lakes, but if we did know what the height of South Lakes is, if we could measure it, then we would just come back in here and alter that that conversion factor, that modification factor, until we achieved the height of the building when we measured it. Okay, that's one way to do this. You also notice that it's hard to get this measurement tool to go away. You keep clicking and it's there. So just click Explore. As soon as you click that tool, you get away, you get back to the finger for dragging things around. And should point out that our roofs are flat. And they're flat because the only height that's given is the tallest height. So these houses all look a little bit bigger than they really are, because although they may have a peaked roof and the top of the house is a point and the same elevation as the top of these flat features, this adds a bit of volume to the houses that's not there. So now I want to try one more thing. I want to zoom out a little bit. This will be the end of this video. And we're going to change our base map to imagery. And so it will replace that topographic map with aerial imagery. It takes a while. It's a lot of data. Okay, there you are. There you can see the cars on the road. And you should be able to, if you want, you can zoom out a bit and you can try to find your house. Okay. All right, and that's all I have for this video. And we will work with Massanutten Mountain next in a separate video, and then I'm going to turn you all loose on Mount St. Helens and Telluride, Colorado. Okay,